To perform the commissioning with a mobile phone, we need WiFi Drive Link module and WEG Liftouch app. WiFi Drive Link module is an accessory that can be purchased separately from the drive. Let's do the unboxing. Into the box, we find the module, a small box to carry the module, and the instruction sheet to recover the manual of the WiFi Drive Link module and of the app WEG Liftouch. WEG Liftouch app is a full responsive app available for all operating systems, Android, iOS, and Windows. For this tutorial, we will use a smartphone which is Android-based, so let's download WEG Liftouch app from the Play Store. To download the WEG Liftouch app, let's open the Play Store and digit on the search bar WEG Liftouch. Let's install it in our device to perform the commissioning. The first message given by the app is that we must give the permission to show notification is needed in order to maintain a stable connection when the app is not displayed in foreground. This notification is necessary in order to receive all the app notifications during the operation. Now we are ready to power on our system and connect to the drive. Once the drive is on, we can start the procedure to connect our mobile phone to the drive in Wi-Fi. If we want to use wireless communication, let's use the Wi-Fi module. Before starting, we must check the last 4 numbers of the serial number that will identify the Wi-Fi network. The number in this case is 5001, and then we can plug it on the drive. As soon as we plug it, the light will become green, which means that the module has created the Wi-Fi network. The name of the network is WEG Wi-Fi 5001. Here it is. Let's now open WEG Liftouch app and follow the procedure to connect to our module. The first selection is connect using Wi-Fi Drive Link, so let's click on it to connect. Here, the app asks to select our favorite Wi-Fi Drive Link because it is possible to store all the devices to which we have already done a connection. Since this device is new, this module is new, we can connect with the new Wi-Fi Drive Link. Here, the app recommends to plug in the module. Look at the green light, and then ask to insert the name for the first time, the name of the Wi-Fi network, which is in capital letters WEG Wi-Fi 5001, and the password, which is by default WEG _ admin. Those are the default network name and password name that can be customized into the drive. Let's click Next. In this way, we have identified the Wi-Fi module and we can connect. This is the message of successful connection. In this pop-up, it is possible to click on Wi-Fi Drive Link settings in order to customize the name and the password of the Wi-Fi module. Let's click on Next in order to jump to the main dashboard of the drive, where we find the model of the drive and the serial number. At this stage, it is possible to select the user level in order to access to the app. We have 4 different user levels: easy, intermediate, expert, and service, as well as the possibility to log in as read-only. In this case, let's enter with intermediate user level, and the password is interim. This is the first level that have the access to the startup wizard. Here we are. The main dashboard is that one where we have on the top some information about the drive we are connecting at, and then the most important information about the status of our drive and our system. To make the commissioning, let's open the Startup wizard here. This is the first selection of the wizard menu. Startup wizard is a guided step-by-step procedure designed for the quick setup of the drive, assisting in the configuration of the main parameters. It includes a series of questions related to the various steps for entering and calculating the necessary parameters to ensure proper operation of the drive and lift application. The first step is the control type selection. The default is ASI SSC, which means sensorless scalar control for asynchronous motors, which is briefly a VF, advanced VF control. In our case, we have a gearless synchronous motor, so we have to select SynFOC, which means synchronous field-oriented control in closed loop. And then let's write it. This pop-up keep our attention on the fact that every control type has its own default in order to speed up the commissioning. And in this case, having changed the default from asynchronous motor to synchronous motor, this pop-up tells us that the drive will perform a low default, and then we have to continue. So let's click on yes. This is another pop-up just to advise the user that we are making a change on a parameter. And this is just a warning to be sure that we are doing the right thing in the most safe way. So we can check, remember for this session, and go to the next step. After the low default, the next step is the selection of the communication mode. The default is parallel I/O. It is possible to select between parallel I/O, CAN open, DCP, CAN 417 selection. In our case, we have a setup with a parallel I/O in multi-speed, so let's write this selection and go to the next step. Encoder mode selection, since in this case we have a motor, synchronous motor with a Syncos encoder, let's select Sinus Syncos and jump to the next step. After that, the startup wizard asks us to insert the data on the nameplate of the encoder. So let's take a look on the nameplate and then fill the data here. The defaults are 5.2 volts for the encoder supply, which is correct by default, and the number of pulses is 2048, which is correct. So we can confirm those default data and then jump to the next step. Next step asks to insert motor data. In this case, we have to check the nameplate of the motor and fill here all the correct data to better calculate the inertia of the system. Starting from the rated voltage we have on our motor is 380 volts, so let's write it. Then we have the rated current, which is 22.4. Then we have the rated speed, which is 255 RPM. The number of pores is 11. The number of pores is a data which is not always available on the nameplate, but it is possible to recover it with a very simple calculation based on a formula. Finally, we have the torque constant, which is in our motor 13.79. Even this data is not always available, and it is possible to calculate it with a simple formula, making the ratio between the torque generated by the motor and the rated current required to supply it. Once we have filled all the motor data, we can jump to the next step, where we find the mechanical data of our system. Mechanical data are already set by default based on the size and version of the drive. Anyway, If we have specific information about the plant, they will be very useful in order to better calculate the inertia of the system and improve control, performance, and comfort. We aren't on a real plant in this test bench, so we will take the default parameters, but let's scroll the data listed. We start from the travel unit selection. Here it is possible to select 3 different travel units in Hertz, meter per second, or RPM. Let's leave meter per second. The cabin speed is the information about the high speed, low speed, and inspection speed up to 8 multi-speeds. For the high speed, let's leave 0.72 meter per second. Then we have the gearbox ratio, which is the reduction ratio between motor and pulley. Being a gearless setup, we will leave 1. Rope ratio is the reduction ratio due to the rope rotation in the shaft between the various pulleys. Then we have car weight, the weight of the counterweight, the load weight, and the rope weight. Let's jump to the next step. Next step is the setting of the multi-speed values. Let's start from multi-speed 0, which is the low speed. Let's leave it to 0.07 meter per second. Then multi-speed 1 is the high speed, which is set to 0.72 meter per second. Let's leave it. And finally, we have the multi-speed 2, which is the inspection speed. It is possible to set up to 8 multi-speeds. After that, the next parameter is allowing us to enable the EBC control. In our setup, we have EBC 500, so let's enable it with this function. After that, we have to set the main important settings for the EBC operation, starting from brake holding voltage. To fill all this data, we need to have a look to the nameplate of the brakes, and then we can fill all the information here. Brake holding voltage, in our case, is 104, which is very close to the default we have. Then we have brake holding power, which is, in our case, 77. Again, it is very close to the default that is inside the drive. Then we have brake power mode. We have 3 selections here: full voltage, boost half voltage, and boost hold voltage. And jump to the next step, which is brake power boost. Brake power boost helps us to define the time for which the output voltage is held, which is equal to the value of the rectified input voltage. In this case, it is 1000 milliseconds, so let's leave it by default. It is already correct. Finally, we are at the end of the startup wizard, where we can perform the auto tuning and auto phase of the motor. Let's start the auto tune, clicking on auto tune still. The message we have is that we have to enable the drive to start the procedure. It is possible to check with a percentage. At the end of the auto tune, the auto phase starts, which is very quick. The pop-up indicates that the procedure has ended, so we can open the enable signal. The next step that is suggested by the app is to save the parameters. This will allow us to remember immediately to save the parameters in order to avoid to lose any data we have inserted and any calculation that the auto-tune has done. So let's save the parameters on the drive. Now we have finished the startup wizard. Typically, at the end of the startup wizard, when we are on a real elevator, we perform some trips up and down with different loads in order to understand if the comfort, the arrival to the floor, the performances, and the safety are in line with the expectation. In this case, we have a test bench, so we don't have any load, and we will just simulate a lift sequence. Lift sequence starts with run command, which is start forward, as well as high speed command. Then we close the safety chain, and the motor starts moving at high speed with the same settings we have done during the startup wizard. Let's imagine that we are on a real elevator, so the cabin is moving now and reaching the floor. So when the cabin reaches the floor, the command change from high speed to low speed. And then when the cabin is arrived, we remove run command and the brakes close. We have reached the end of this tutorial about the commissioning of ADL550 variable frequency drive for elevator application. We have gone through all the most important steps related to the wiring and to the parameter configuration for a multi-speed setting. Of course, all the information, the complete informations are available on the manuals of the product that are on WEG website. We hope that you found interesting and useful this tutorial, so let's keep in touch to the next one.